Okay. First of all, thank you for coming here and listening to the talk. I'll probably do some context setting before we get into the session. This is not about what of data mesh. I'm assuming that most of you out here know or have dabbled with data mesh or have gone through the literature at least. This is about the how, the aspects of implementation patterns, which is of course driven by a set of guiding factors, and data networks, so commerce of data products between or amongst the consumers, the producers, and the users, which are enabled through self-service platform. So what we'll do is we'll go through the experience that we have had so far and share some of the implementation patterns and then see if it resonates with you guys. Okay, so let's start. What we have so far architected and we are about, or we have started implementing, is with an emphasis on domain data and with a view or with an emphasis on some of the guiding principles that we have from a data mesh architecture standpoint, which is number one, serving the application or the consuming application needs, as well as discovery of the data products to marketplace. You would have heard of the term data marketplace in today's keynote speaker sessions as well, but we have actually gone forward and we will share about the architecture that we have and the implementations that we have from a marketplace standpoint. So discovery of data products via marketplace instead of the usual ingestion, extraction, and loading, right? Sync of data either on demand basis or through event-based architecture, either continuous streaming or through a micro batch kind of a thing, with a focus on data as code so that we can scale it up instead of moving the data via pipelines through batch bound, okay? However, as we'd all appreciate, there is no one size fit all, so we have a set of implementation patterns which are guided by some of the deciding factors, and some of them are like nature of the data sources, so depending upon whether it's a streaming data source or a legacy through which we can have some CDC or log replications-based CDCs happening, the historical data needs of that data product, given that at times we had instances of the data being consumed by AI applications. Then the serving application. The serving application can be a REST client, or it can be a BI dashboard, like a Looker or a Power BI dashboard. And the last factor was consumption patterns, as in consumption requirements. So for example, if we have to drill down to transactional data during the time of slice and dice of the data, right? So those are some of the deciding factors that we had for coming up with the implementation patterns. What I will do is I'll request Kane to go through some of these core implementation patterns, and then we'll come back and we'll talk about how we are leveraging some of the self-service platforms to create and design the data products, as well as disseminate it through the marketplace concepts. Ken, over to you.
Thanks, Shankalan. I'm an architect at McKesson. McKesson, if you don't know, are one of the, we're a Fortune 5 company, and we're a very large distributor of pharma, as well as having some healthcare provider practices as well. We're going through this digital transformation journey now, and one of the challenges that we have is our data acquisition, our data federation patterns today are extremely diverse. We have a lot of legacy technologies, and quite frankly, how data moves through our organization and is ultimately used for analysis or decision making is, well, it's complicated, and from an operational reliability perspective, there are gaps in that approach. So when we look at data mesh, we wanted to look at how do we consolidate those patterns to the minimum possible, so we have better controls, better levels of governance, and really just a simpler landscape to support data mesh. So how many folks have actually engaged in building out a data mesh strategy or feel like they have a data mesh? Okay, so maybe only 10 or 15%. But as our objective is to really narrow down just the number of patents that we have in the organization. And so we have 5, I think, today that we're going to share with you. And these are probably the absolute bare bones that we could move towards. In reality, I suspect that we're going to have variations on these, and we'll probably have many more. But each one of these patents has kind of a common center section here that shows our source databases. And really, this is kind of how we surface data to the data mesh. We're not talking about ingestion necessarily, because we feel like we can virtualize data without actually, creating additional copies in the Delta Lake in every case. So this middle section is how we surface data, and this is something we've been working on as a strategy probably for about a year, and we've made a lot of progress in this space. But generally, there are 3 technologies, 3 approaches that we're using to surface data. One is pub/sub or streaming, and we're using Confluent Cloud as our platform for streaming. And we're shifting a lot of our source systems to event streaming so we can capture those events. The second one is CDC, and kind of a last resort approach to capturing everything is to just replicate the data using a CDC tool. And we've landed on some enterprise choices there for just replication. And the last one is API. A lot of the technologies that we use, a lot of the source systems that we use have API technologies. So you'll notice in that center section, we don't have file ingestion. We're really trying to land on those 3 kind of methods to surface data. Just a note, really, between pub/sub and CDC, one of the downsides, you guys know this, one of the downsides to CDC is we just have table data. And table data is not really consumable, so it requires a lot of downstream processing, whereas pub/sub tends to be business events that are very consumable. So we're really favoring that kind of pub/sub mechanism as a way of surfacing data. In this first implementation pattern, we have perhaps the most basic example where we've got a consumer, maybe it's an application, that is really close to the original source data. So it may be able to interpret the data, understand the schema directly, and that's pattern A. Our approach through pattern A is really to prefix the consumption with functions of the data mesh. So you'll see API gateway there, which is a mediation layer, and you'll see governance and microservices there, which are really functions of our data mesh. And those are functions that we're building out to support the overall mesh. And we'll prefix kind of access to those source systems through those functions. For pattern A, we do have issues of scale and load with some of our source systems. So we've got a lot of databases and a lot of source systems that can't scale. So we have a cache function there as well. And then path B, or pattern B, is slightly different here because rather than accessing the source system directly, we're going to essentially a replica in Delta Lake as the source for that data. We may land data first in file storage and then use structured streaming to do data quality management, to do enrichment into our Delta Lake. So that's the first pattern and perhaps the most simple. In the second example, we have a scenario where the source data on its own, it requires enrichment. And so there's more effort required in the structured streaming area to create an enriched product. How we surface data to this approach is exactly the same as the first, right? We've got pub/sub, CDC, and APIs. But in pattern 2, where we have an enriched data product, we've got 2 options. First is using a virtualization tool. So think of Denodo, Starburst, those kind of tools. And here we've got the same API gateway for mediation, the same functions for governance and cache that we had in the first model, but governance is actually also applied in the virtualization layer. And that's an excellent place to actually provide that function. But we've also got business logic that's kind of duplicated in the enrichment of data between the virtualization layer and the structured streaming layer in the Delta Lake. Here we've also got 3 layers. We have bronze, which is our raw data, silver, which is our semi-curated DQM data, and then finally our instances of deployed product in our gold layer. So a little more complex there for an enriched data product. And consumers of this will be, potentially analytics scenarios as well as applications and some other scenarios there. In pattern 3, this is kind of for our analytics products, so like dashboards, think about Tableau or Power BI. And we've got some slightly different requirements in these areas because we don't only need two-dimensional data, we need to drill down as well into kind of aggregates here as well. Again, we've got 2 different paths for our analytics scenarios and for our patterns for analytics scenarios. One, again, using data virtualization products, and the other using our Databricks Delta Lake scenario. Again, how we surface data is exactly the same as the other 2 scenarios. So using this approach, we hope we can kind of rationalize the number of approaches that we use in the organization to collect data and to surface it to different consumers. Our objective really is to get to a point where we kind of codify all of these pipelines so that we can deploy these scenarios using CI/CD methods so that they're consistent, so that we can improve those incrementally and deploy them and redeploy them where we need to for scale. And that'll give us a lot more consistency in our operations, much more than we have today with the huge diversity. I'll turn it back over to Shankalan now.
Sure. Thank you, Ken. So what I'll now focus on is how do we enable all this, the core or the foundational implementation patterns that Ken was talking about. The first and foremost thing was about our data marketplace, okay? You heard about the announcement today, but I think we're a little ahead of the game here when we thought of getting the data marketplace in production here. Quite a few things in the data marketplace. So data marketplace is for the consumers to come and shop for the data products and see if that data product is of use to them, and then go ahead and consume it if required, okay? So the first and foremost thing that we wanted to build upon is the search functionality. The search is not just on the metadata itself, so the search is on the data values. So we have the API calls not just to the backend data catalog solutions, but we put in cognitive search on top of it so that we can go ahead and search. Of course, it has to be indexed, and it would not support polyglot storage, but we fortunately had storages which was supported by the cognitive search APIs that we're using, right? The second thing out here was to get a lot of details about the data product itself, right from the technical metadata, looking at some of the glossary information to see if we can have annotations coming in. So we had put in an annotation SDK at the back of it to see if we can surface PIBI information so that the consumers can know about the tagging right at the outset, okay? Looking at the personalized delivery. So the delivery of data products was done in a couple of ways. One was query as a service. So we put in query as a service through a data federation kind of a tool at the back of it, so that you can go ahead and one can go ahead and federate the data across the storages between ADLS and a data warehouse solution, as well as to kind of have the facility within that marketplace itself without they going to another SQL client or another client to go and query the data. Also having a personalized delivery through an API webhook so that the data product can be delivered to a particular storage location if that is a need, okay? We put in a lot of functionality from a profiling and a quality point of view, from a data profiling, data quality. So we were able to, at a real-time basis, look at the different entities of the data product and then do a critical data element calculations or surfacing critical data elements and then profiling those critical data elements with a lot of statistical information, including standard deviations and so on, so that the consumers understand the shape of the data. And then we're also surfacing the statistics of the data quality. If the producers were putting in some data quality measures, the statistics of that was also we were able to view that in the data marketplace. Important thing that we built in was a knowledge graph. So we were generating the knowledge graph at the producer portal, which I'll come and talk about in the next slide. But what we're trying to do is to show to the consumers how the different entities of the data product, so there can be 10 or 12 entities of that data product, how they're related to each other at an entity level or an attribute level. And the back of it, we are using some automated mechanism based on the glossary information that has been put in. So there's an NLP model which works at the back. There's a statistical model which works at the back. And also we're looking at some of the distance measurements, cosine and Euclidean distance measurements, to come up and give a matching score at an attribute level to see how these entities are then related to each other on the fly without having a lot of effort coming in from a data modeling standpoint, okay? Now, from a construct point of view, we have the Flux app. So we have the Python SDKs there. There's an API gateway in between, which helps us to do all the mediations and the token management. And then, importantly, if you look at the right-hand side, we have some third-party tools which you have to use, the data federation tool which is talking about, the data catalog tool which is talking about. But we developed this data as a code, so low-code, no-code frameworks and Python SDKs, all working on Databricks, which was helping us to do the data quality, the synthetic data generation, annotation engine which I was talking about. We are also collecting a lot of session information, so in terms of the logs, so that we can use that to have further feature developments and improvements depending upon how the experience is at the customer marketplace level. Okay, so that's more about from a consumer coming in and looking at the data products and how we are giving more information for him or her to take a decision of then consuming that application consuming the data product for their application. But in the light of having a self-service data platform, what we then thought of, how can we have the data generalist come and create their own data products, design and create their own data products? And that's where the producer portal came in. Okay, so the producer portal that we have put in place, again, it's a custom application, it's a React application, but what we are able to do as part of the producer portal is to give ability to the data generalists, people who don't know a lot of Python, who don't know a lot of PySpark and so on, to have the ability to design the data products, which is the enriched data products. There's a few things there that we are enabling as part of the producer portal. One is the onboarding of the metadata. And the onboarding of the metadata can be based on the data source, which is already being ingested, because we are not kind of starting from clean set. Some of it has had data which were on the raw data lake itself, or if we have to hook up to the source. But onboarding the metadata to enable the producers then start defining the glossary information or look at the metadata and see if there's an update or edits required to the metadata. So, and then have all these abilities from a compliance perspective or annotations perspective, which is coming in as a custom capability for them to understand what is PI, what is BI, and then set the data usage rights accordingly, right? So at an attribute level. So you would have the different profiles of the users, and then through the clicks of cross or tick, they could then kind of say which attribute can be viewed by which kind of personas, okay? We also built in a DQ designer. So we had a kind of comprehensive solution that we had built in, which was probably about 9 rule categories, 80 odd different rules at a column level, row level, file level, and so on and so forth, which can easily be dragged and dropped, right? So think it from a data generalist who understands the data structure, who can then go ahead and design his or her own DQ rules on top of that, different entities that you have onboarded, maybe 10 files, 15 files, whatever, or whatever that data product would constitute of. We also built in the curation and the enrichment designer. So the curation is more at a particular entity level. The enrichment is how you bring those data to enrich and create, for example, a fact table, where we could do a lot of complex things like derived key processes. So it can be derived key based on case conditions, for example. Right? So we built in all those, as well as if there needs to be joining of two streaming data sources, or for example, if a lookup has to happen with a more stateful data, all of those were built in as part of the enrichment designer. Again, drag and drop approach, so the data generalist are people who are more shadow IT, I hate to use that word, but or people who are more source aligned IT could go ahead and create their own enrichments, okay? One cool thing that we had, and I talked about the entity relationships or the linkages in the producer portal, in the consumer portal conversation, but in the producer portal, we are actually surfacing that capability up so that the data publisher can actually go and see what the system is throwing up as what the system is throwing up from a hint point of view, what are the linkages at the attribute level. They could then go ahead and select if they want to and say, okay, this is the this is the linkage, or they can bring in their own user-defined linkages if they know the data structure and if they understand the relationships between the attributes, okay? So that's kind of a semi-automated data modeling, as you call it, was baked in as part of the producer portal. Again, on the right-hand side, we are talking about the third-party tools, data catalogs, and data federation engines. One thing which I forgot to probably surface up is the curation and the enrichment. There's an ability to kind of select in the deployment portal, which is my next slide, to see where this data product would be implemented, whether it is to be on the virtualization solution on Trino or Starburst, or whether it needs the data product is persisted and we would have the compute as Databricks. Okay, so based on that, it is the same designer, but it's based on the decisions, and the decisions were based on, again, the volume of data, consumption patterns, and so on. You could really have a low-code, no-code approach and have the compute shift from Databricks to this data virtualization solution, or other way around as well. Okay. Yeah. Then we again thought of how do we deploy this. The producer portals is good from a data generalist standpoint, but how do you deploy that through one-click solutions where the data mesh platform guys, this is like the core technical specialists, the IT guys would come in and do the deployment of the data products through one-click solutions. So there are two aspects to it. One is, and probably Ken touched upon, the deployment of the landing zone itself. So in a data mesh construct, and given McKesson kind of diversified organization, we could have multi-cloud solutions or separate resource group. Even if it's an Azure, there's separate resource group, separate storage, separate compute for the units or even the sub-entities within those business units. Okay, so how do we have a one-click solution for deployment of landing zones, as we call it? That was one part of it from a deployment portal point of view. And second was actually deploying these data products, for example, to the streaming pipeline. So having all the details being captured as part of the deployment portal. What will be my path? What will be the checkpointing path for the checkpoint data to be stored there. The watermark column, if I have a non-streaming sync, for example, what will be the SCD2 type 2 column? All those details would be captured as part of the deployment portal, so that, again, when you deploy the data product, it can be deployed through a one-click solution on the virtualization solution or on Databricks, okay? We have a future plan of bringing in more monitoring of the environment also, or the data products itself into the deployment portal. But at this point of time, we're just focusing on deploying the data products as well as the landing zones if there's a new landing zone that needs to be deployed. I think that's probably, I'm looking at the watch, there's one more slide to cover. Ken, why don't you help us in concluding the benefits that you have got through this approach?
Yeah, I just want to reiterate one thing that Shankar mentioned around the producer portal, which is really a way that any generalist can create a data product. And as you know, data mesh is centered around a data product philosophy. And we really feel like the producer portal will allow us to crowdsource the production of data products, right? And what could be better than that? I think the more products we can get into the data mesh, the bigger market we'll be able to cover internally. And that crowdsourcing approach, I think, is pretty close to the users as well. They want to contribute. They want to feel that sense of accomplishment of getting products out there. And just on this slide, on the deployment of data products, we've got a lot of folks that are used to different environments. We want to be able to support the environment that they prefer. We want to be able to deploy to any preferred environment, and really kind of just federate that responsibility for the deployed version of data. So in our journey towards kind of digital transformation and how the data mesh fits into that, we feel that this approach is really going to help us get kind of a faster time to market, or a faster time to value, or it'll help us fail faster too, right? So there's a lot of times when analysts have ideas from data. Sometimes it might take 6 months to disprove that. We want to fail faster, or we want to realize that value faster. It's going to create less diversity in the platforms that we have to support. And that's a great thing, just from the operational knowledge, the skills, the service level that we'll be able to provide. It'll also give us kind of more of a focus center to implement our governance mechanisms. And we didn't drill into that, but obviously governance and security are very important. So it'll give us kind of a closer core to focus on rather than a big diverse platform. We mentioned less dependency on tech specialists and leveraging generalists and crowdsourcing. And another big issue for us is scale, right? So we have a history of shared database models, and those do not scale, right? So you get 500 people on one SQL server, you start to get scale issues. This model will give us the ability to scale and to improve our performance of most of our jobs. Looking forward and looking further down the path of our digital transformation journey, we will have an AI marketplace. So just like we've got a deployment portal, we'll have kind of a version of that specifically for AI and ML, including a data science workbench. And then lastly, and this was in the keynote, so they stole the idea from us, we want to have a data marketplace for our external customers too. We share a lot of data with drug manufacturers and with pharmacies, and we do that in a diverse approach right now. We want to use the data marketplace concept to really to rationalize the way that we share data externally and the way that we consume data from our partners. So that's a little about our data mesh journey. I think we've got a few minutes for questions.
Question? Could you please pass it?
Thank you so much. Fascinating talk. So my question is, I think you mentioned a little about semi-automated and automated data modeling, like trying to identify sort of the relationships between different tables. That sounds very interesting to me. I was wondering if you could like speak a little more about that, or if there's like, you know, some state-of-the-art like technology, like models that you've used for that. That's all.
Yep, I'll take that.
Sure.
Yep. No, that's really fascinating because in the yesterday's world, we used to spend a lot of time doing data modeling and then trying to fit the data to an industry data model. Here, what you're talking about is a data model at a data product level or maybe at a subdomain level. And what we're trying to do, of course, there are certain prerequisites. The glossary terms needs to be defined properly. So what we are trying to do through the semi-automated, I will not call it automated as of yet, and it will never be probably, is to able to do three things essentially that we are doing. One is based on the glossary information or the definition that has been is there as at an attribute level. We are having a BERT model, an NLP model at the back of it, which helps us to understand the relationships between those attributes. So that is point number one. Point number two is we are looking at the statistical spread of the data. So between attributes, so you would look at the left-hand side and the right-hand side, and you will get the statistical spread of the data. So there's another model that we have. And the third one, we're looking at the distribution. So we're looking at the distance measurements between the different data values, the Euclidean distance, mostly the cosine distance of the data. And we are then calculating an average score. So the weightage depends upon where you want to give the more weightage. At this point of time, the weightage is more on the semantic relationship of the data. But we can play around with the weightage. It's pretty configurable. And then we're putting a threshold there. And again, the threshold is very configurable. So what we are doing as part of the producer portal is anything which is above this 85% weightage, or 85% score, we are surfacing it up for the data publisher and the developer, and then allowing them to take a call, okay, whether it's correct or wrong. And they can, again, put in their own relationships if they want it. So it's kind of force-fitting user-defined relationships. So we're enabling that to the producer portal, and once it is done and approved by the data owner and the steward, we are surfacing it up as a knowledge graph on the consumer marketplace. Did it answer your question?
Yes, definitely.
Thank you.
Okay. Any other questions? Yes.
Hello. I just want to know a little bit more about how was your experience on like splitting or grouping all the data products into domains. How was that journey? And then how, if you manage, how you eventually you need to move like one data application to one domain to another domain. How was that impact, and if you have that contemplated in the platform?
Yeah, so you want to answer the first question, I'll take up the second one.
Yeah, from a data mesh perspective, we see this as domain driven. And typically we have had silos of business units or technical systems that have kind of organized or produced data. We're switching more to a functional view so that we get alignment across technical systems and across business units. So when we talk about products, we're talking about enterprise-wide products. So how we organize domains and how we organize the responsibility is really a functional approach. There's some exceptions to that, but that's our intent.
Yeah, to your second question in terms of the relationships of data products across domains, the same technique that we're adopting, it's a little bit of a lag because once a data product surfaces up, the data products for the other domains, they need to rerun that thing to find out if their data product now is related to the new data product that has surfaced up or not. But that's something which is a refresh cycle, which is really a little bit on a batch mode that has to happen to understand if the new data product that is surfacing up is related to the existing data products or not.
We're also using things like popularity, right?
Yeah.
And allowing folks to vote on best products, right? And look at consumption so that we get a little bit of competitiveness around what's the best
statistics.
product.
Yeah, so we have the trending statistics also, which number of data. So which are the data products which are hot now, stuff like that.